A self-driving car's radar continuously sends waves to measure the distance to other objects. A wave takes 50 nanoseconds to travel to a pedestrian and back. So now let's look at this image. We see it takes 50 nanoseconds to travel to the pedestrian and back with the car. So let's just read the question once. Using information in the formula sheet, calculate the distance between the pedestrian and the car. You should use the speed of light as 3 into 10 to the power 8 meters per second and give your answer in meters. So now, as we need to find the distance, we know the formula of distance is equals to speed into time. Now we know the time as well. The time is 50 nanoseconds, but we need to convert that into seconds. So 15 nanoseconds to seconds. So you'll have a formula sheet in your paper. So in your eAssessment thing, I think at the top over here you'll have an option for a formula sheet. So when you click on the formula sheet, you'll be given SI units. So you can use the SI unit and you can convert the 15 nanoseconds to seconds using the thingy. So if we convert it, we will get 1.5 into 10 to the power minus 8 seconds. I can't put the minus 8 in power, but if you do, you just put minus 8 in power. And then as we converted this into seconds, we know the speed of light as well. Speed of light is 3 into 10 to the power 8. 10 to the power, I can't put it in power, you have to do it meters per second minus 1. You just copy paste this over here and you'll get it, the speed of light. And then after this, just use the distance formula. Distance is equals to speed into time. So we just get distance as 1.5 into 3. So the distance is just going to be, we're going to get the distance as 4.5 meters. But there is one thing we need to keep in consideration, take into consideration, my bad. If we go and look at the image, we say that, if you look at this thing, it says that, let me just move this, it says that the wave takes 15 nanoseconds to travel to a pedestrian and back. So when it goes, it takes 15 nanoseconds to go to the pedestrian and come back again. But in the question over here, they're asking us the distance between the pedestrian and the car. They're not asking us the entire distance that it takes to, it goes and comes back. So we're just going to divide 4.5 by 2. It's going to give us 2.25 meters, because we're only calculating the distance between the pedestrian and the car. The total distance, if we go front and back, is going to be 4.5, but we don't need that. We just need the distance between the pedestrian and the car. So we get this as our final answer. So that is it. Now we're officially in the last question of the paper, which is question 8b, and you can score 14 marks for this, so be careful while answering this question because it's easy marks, to be honest. As a person who solved the 2026 M26 paper, it was not that hard, and you score most of the marks in these like 14 markers, 12 markers, whatever it is, because these are the questions you can score the most in because they don't require you to write a lot for them. This might seem overwhelming when you look at it at first glance, but it's not. Just write, you can just write it in pointers and you can still score marks, but you have to be very specific, and what you write, it has to be clear to the examiner. So let's just look at this question first. We don't need all of this, we just need this part. Let's just read it. Using all of the information provided and knowledge from your wider MYP studies, discuss and evaluate the use of self-driving cars. In your answer, you must include an explanation of how these systems and technologies work to replace humans in self-driving cars, the ethical consequences of a self-driving car making decisions normally made by humans, the positive and negative economic impacts of self-driving cars, and then your opinion about whether self-driving cars should be used everywhere or not. And as this is for 14 marks, let's just break down the markings. So for these we need 4 marks go for this, 4 marks for this, 4 marks for this, and 2 marks for the opinion or the conclusion, whatever you say. So for this we can write 4 points. So let's just get started with this one. So to give an explanation of how these systems work, we have to just go and look back at the images over here. We have to just interpret these images. They gave us an infographic where we can just hover over them and we'll see the different functions of the different systems and technologies in the car. So first let's get started with the radars. Let's just break them down. So what these, let's just read this and next let's interpret them. So let's just read what the ultrasonic radar does. The ultrasonic radar, it detects nearby cars or curbs using sound waves to help in parking. And next, for the normal radar, it views and detects objects based on the distance using the radio waves. So after reading both of this, we can understand that both of these radars, they detect the distance and the speed of nearby objects, which helps the car avoid the collisions and also assists in parking. So that can be our first point. The first point can be the radar detects the distance and speed of nearby objects, helping the car avoid collisions while also aiding in parking. So that can be the explanation of what the radar does. Then for the LiDAR sensor, we can just write the LiDAR sensor. We know that it creates a 3D map of the environment around the car, and this helps the car in detecting the objects and telling the difference between an animal and another car. So it knows what it is. So like, it just does not classify a random object as a car. It knows what the object is based on its 3D mapping of the environment, and it can allow the car to identify roads and certain obstacles. So it knows what is in front of it and just doesn't randomly make assumptions. So that is the role of the LiDAR sensor. This can be a second point. You just write LiDAR creates a 3D map of the surroundings, allowing the car to identify roads and obstacles. And then we have our GPS, which is the GNSS. So the GNSS, it communicates with other self-driving cars while also registering other vehicles' location and speed. This it's a bit expensive again, and the thing is, this system, it basically helps in determining the vehicle's location and calculating efficient routes, and they can continuously track the vehicle's position more precisely than a human driver. So that is what the role of the GNSS is. It's basically like a GPS, but it's more advanced, and it basically communicates with other cars. That's another plus point of this one. So our third point can be the GNSS systems that determine the vehicle's location and they calculate efficient routes. They can also communicate with other self-driving cars. They can register other vehicles' location and speed, and they can continuously track the vehicle's position more precisely than a human driver. So for example, let's say that you are lost in, let's say, Hyderabad. For example, let's say you are lost in Hyderabad, which is a city in India, and you don't know where you are, but this system does, and it can basically get you out of there. So it is more accurate than you in making your, it's more precise than you in making decisions and knowing where you are. That is the role of the GNSS systems. And then we have the camera. So the camera, it basically, what it does is it recognizes traffic lights, road signs, pedestrians, cyclists, other vehicles, etc., whatever obstacles are there. And then the camera, it has an, I think it has an AI embedded in it, because the AI basically processes information and decides when to brake, accelerate, or steer based on the input that the camera gives it. So that is the role of all of these. I think we broke it down. That can be our fourth point. So now let's just go over to the question and let's just write our answer. Let's make it. So first let's write explanation of how these systems and technologies work to replace humans in self-driving cars. Boom. Just put this over here and let's get to our answer. First point is going to be about the radar sensors. The radar and the, I think it was ultrasonic. Let me just go back and look at it. Yep. Ultrasonic radars use radio and sound waves to detect the distance and speed of nearby objects, allowing the car to avoid collisions and aids in parking. Next, this can be more accurate than human judgment when it comes to estimating distances and parking in tight spaces. That's the first point. Second point is about the LiDAR sensors. So the LiDAR sensors. LiDAR sensors create a detailed 3D map of the surroundings, and they identify objects, road markings, and road edges or curbs, whatever you can call it. So what this does is it basically allows the vehicle to detect hazards even in darkness, and it can help the car make driving decisions without human input that is necessary. It can identify objects, and I think it can also categorize them. Identify objects. Categorize. This can also go categorize the objects. That's it. Now let's just write how this helps the vehicle. How does it help the vehicle? So this basically allows the vehicle to detect the hazards even in darkness, and it helps the vehicle make driving decisions without the need for human input. That is the role of LiDAR sensors. And for the third point, we can just write the GNSS systems determine the vehicle's location and calculate efficient routes. So it acts as a GPS basically, but it just it calculates efficient routes and it helps determine the vehicle's location. It's basically GPS. The thing is, what makes it different is that it can continuously track the vehicle's position more precisely than a human driver. So just write the GNSS system can continuously track the vehicle's position more precisely than a human driver. That is the role of the GNSS system right over here. And then we have our cameras. The cameras have AI softwares built into it which can recognize traffic lights, road signs, pedestrians, and other vehicles. the AI processes information and decides when to brake, accelerate, or steer. This is coming in between again, so let me just move this over here so it doesn't get in the way. Let me just move the entire thing down here so we have more space and we can understand it better. Yep. I don't think we need to mention the AI part over here. Cameras, let's just recognize, because it's more extra. Only we need to mention this AI thing is that this can help the vehicle decide when to brake, accelerate, or steer. So that is the function of the camera. And then steer, and can helping it follow the traffic rules, and it can prevent breaking certain speed limits as well. This is right. That's it for the first 4 points. These are what we're gonna write, and then let's just go to the ethical consequences. And this is gonna be fun. Ethical consequences they're always fun. So first thing is that the first point can be that self-driving cars, they might have to make life or death situations sometimes, because you never know what can happen in the road, because you might be stuck in some very unfortunate circumstances, and your accident might be unavoidable. For example, let's say that you're stuck, a truck is speeding at your 120 kilometers per hour, you have nowhere to go. So the self-driving cars have to make the life or death decisions to save your life, and it may not be appropriate for a machine to decide whether to prioritize passengers or other road users. So you don't really know, because how could you trust a system to decide to whether prioritize your life or others on the road? Because to save you, it might also cause trouble to other people on the road. So as it is a system and it is a machine, it's not a human. It cannot make human like decisions. So it is not appropriate for a machine to decide whether you can put your life in risk to save others. So that's one ethical concern. We can just write self-driving cars may have to make life or death decisions during unavoidable accidents. It may not be appropriate for a machine to decide whether to prioritize the passengers or other road users. That is our first point. And the second can be the self-driving cars, they have to collect a lot of data about users. So this raises concerns about the privacy, and then it can also raise concerns regarding how personal information is stored and how it is protected, because you don't know what information they might collect about you, and it raises concerns about transparency as well. So this can be our second point. Self-driving cars collect large amounts of data about users and their surroundings. This raises concerns regarding the privacy and about how personal information is stored and protected. Because if the database has hacked all of your information, it might be exposed to hackers or whatever, and your privacy might be at risk. So that is one ethical concern. That's the second one, And for the third one, so as they asked us to evaluate it, you have to look at both sides of the coin. Let's look at the command terms. So we have to look at both sides of the coin. As it's evaluate, we can go for a positive one as well. So we can just write, unlike humans, autonomous systems are not affected by let's say human factors. I mean, human made errors such as distractions, being drunk, which we can also call it intoxication, and then fatigue as well. So this can make the decisions more consistent, and like it can also make them more potentially safer because they're not affected by these factors that can affect humans. So that's another point. Are not affected by distraction, the phone example, the intoxication, or fatigue. This can make their decisions more accurate, consistent, and potentially safer for the, what do you say, okay, for the passengers. This is one. For the last point, um, let me just think. That is all thing actually. You guys can write your own answers as well. For the last point, we can just write. It can be difficult to determine who is responsible if a self-driving car causes a crash, because it's really confusing, because the car is self-driving and it's driving its own thing, but you're the one that's responsible for it because you might be the owner, but at the same time you're not, because you are the one who's not driving it. The car is the one that's driving it. So there's a series, I don't think I remember the name, but what happens in that is that there's a little girl who was traveling in a Tesla, and then not a Tesla but a self-driving car which her dad made, and then she runs a what do you say, a speed limit, and then the police comes and says, he just looks at the driver, but there's no one inside the car, and he doesn't know who to find. So that's how it is, because if you crash into something, are you responsible or is the car responsible? You don't really know, because you're the one that owns the car, but you're not the one that's driving it. So yeah, we can go for that. It can be difficult to determine who is responsible if the self-driving car causes a crash. So that's our fourth ethical concern. Yep, we're done with the ethical consequences. Now let's just go towards the economic impacts. So as we were asked, the positive and negative economic impacts. We can write as it's, you need two for each, I guess. Two positives and two negatives. Positive economic impacts. Let's just write the positives. Let's just think of the positive economic impacts. As we're driving self-driving cars, they reduce the risk of accidents. So these fewer accidents could potentially reduce the healthcare, repair, and insurance costs in the long term. With that, fewer accidents could reduce the healthcare, repair, and insurance costs in the long term. The second one can be, passengers can actually work while they're traveling, because the car is driving for you. You're not driving the car, and you get that sense of safety as well, because the thing knows what to do. So you can work while you're driving. Not driving actually, but work while you're sitting in the car. Passengers could work while traveling, increasing their productivity. That's the second one. Then let's the negative economic impacts. Let me just hold on a bit. Yep. So negatives, you can just write they're very expensive, right? The self-driving cars there are many negatives actually. One can be professional drivers may lose their jobs because the self-driving cars may take over, and it reduces human errors, so no one would trust a human anymore. But I think that's unlikely to happen. Let's just write drivers, let's just write professional drivers. Professional drivers may lose their job. Second one can be the cars they're very expensive to maintain. So instead, self-driving cars require regular maintenance, are expensive develop and maintain. Which increases whenever we just leave it at here. That's it. Boom. That's right here. So that's it for a negative economic impacts. Now let's just go to the opinion. My opinion can be self-driving cars have. No, let's start with while, because it sounds cooler. Yeah. So let's just start with while. You can start with anything you want, but I just go with while. So and just write while self-driving cars. I believe let me just discuss my opinion. So while these cars, while they have the potential to reduce the road deaths and they have the potential to reduce the accidents by removing the human errors, they can do this. But the reported crashes show that the technology is not yet fully reliable. So we saw that there were 400 they were by looking at this, the US National Highway Traffic Safety Administration thingy, we've seen that there are reported 400 crashes involving these self-driving cars. So we know that this is not fully reliable yet. We don't know if it's fully reliable. So that's a problem. And then I believe that they should not be introduced everywhere immediately, but it should be done gradually. So they have more time to invest in the technology, they have more time to develop the cars, and there need to be strict regulations that need to be enforced to ensure that the accidents are reduced and actually the ethical concerns are mitigated as well. So yes, right, while self-driving cars have the potential to reduce road deaths by removing human errors, the reported crashes show that the technology is not fully reliable yet. Therefore, I believe that they should not be introduced everywhere immediately. Rather, they should be introduced gradually with strict regulations. That's it. To reduce the risks associated with them. And that's it for our last question. I hope you understood. So this is that simple. You don't need to write a lot. It's just a few pointers. And that's it for this question.